The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so for number 5, we're trying to find the range of a trig function. In this case, we have 1/2 secant 2x plus pi. So the important part to note about this is that even though this function that we're given is not necessarily the easiest one to graph, we're only finding the range. So this is actually kind of a trick question that's a lot easier than it seems. Because if we only need to find the range, there's only a couple pieces of information here that even matter in the first place. First of all, we have a secant function. You should know what that graph looks like. I'm going to graph it here again. But just knowing that we had secant is going to tell us a lot. Because on a secant function, we have a bunch of loops and vertical asymptotes that look something like this. And these points right here are at -1. This point right here is at 1. And of course, this continues forever. So that's just what our normal secant graph looks like. So remember that the range is just the possible y values. Well, all of this stuff in here, this 2 and this pi, that's changing. That's like a horizontal stretch or compression. It's shifting it. That's moving the graph and doing a lot of different things in the x direction. Shifting this, compressing it, whatever. None of that is going to affect the range because, yes, this graph might get narrower or it might move over, but if you're just talking about the possible y values, that didn't change anything. The only thing that actually matters here is that you have a 1/2 in the front, because what that means is that all your y values are going to be half of what they were. That is important to the range because now, regardless of what we did left and right horizontally, this point here that has a y value of 1 is now going to get halved to 1/2. These values here that have y values of -1 are going to get halved to -1/2. Now the graph is still going to go up to infinity there, so that doesn't change. So now what are our possible y values? Where we could have anything as far down as we want, -infinity, up to this -1/2. And we actually have a bracket there because now our loops are all going to start at that 1/2 and -1/2. So keep in mind here, I disregarded all of the horizontal dimension shifts and compressions because they don't affect the range. And then we also have everything from 1/2 and higher. So we have 1/2 to infinity. So this right here is our range for this problem. So you can, instead of trying to graph out this entire function, because you knew you were looking for the range, immediately you can disregard any x direction shifts, any horizontal stretches or compressions, and if you saw that, this problem became a lot easier than it might have seemed. So that was answer choice A.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.